Okay, here we are. Welcome to everyone. The first one says a rock is dropped from rest from a height of 200 meters. Okay, it's dropped from rest down 200 meters. So the distance is going to be 200 meters. Right? Now that is going to be free fall, correct? If it's free fall, what is the acceleration going to be? If it's free fall, what's the acceleration going to be? 10 what?
Meters per second squared.
10 meters per second squared. So as I drop this, what's going to be the velocity at the end of the first second? 10 meters per second.
Yeah.
What's the velocity going to be at the end of the second second? 20 meters per second, correct? Right? What's going to be the velocity after the fifth second? 50 what? 50 meters per second. You get it? So it's going to accelerate g, which is plus 10 meters per second squared. Clear? Any questions with that? So the rock is falling. It's free falling. Correct? It's free falling, and it's going to increase its velocity at the rate listed here. So far, so good? Yes? Now, it says, how long before the rock hits the ground? How long before the rock hits the ground? Now, we have three equations. Let's put them up here now, okay? We have three equations for this chapter. There's a lot of minor equations like average velocity equals d over t, correct? But what are the three major equations for this kind of motion, straight line motion? It's right on your equation sheet for mechanics that I gave you. It's going to be final velocity equals initial velocity plus what? Plus a delta t, correct? Is that correct?
Yeah.
And what's the next one? Vf squared equals what? Eustace? You're going to take out the mechanics equation sheet. Equals what, Mohammed?
V initial squared
V initial squared
plus 2a delta d.
plus 2a delta d. What does that mean, delta d? What does that mean, delta d? What is this? This is all Greek to me. What does that mean, delta d? What does that mean?
Velocity times distance.
Change. Delta means change, right? It's a Greek letter. Is that a capital delta or a lowercase delta?
I think it's a capital.
It's a capital delta. Excellent. Capital delta, right? Triangle. And it means change. It means other things in science as well, but in physics it predominantly means change. Okay? Yes? In chemistry it can mean, believe it or not, it can mean heat from an external heat source.
Yeah.
I take magnesium plus oxygen, and then you put the yield sign. Well, over that yield sign I put triangle. That means I'm heating it. Okay, I'm heating it. I'm going to get a lot of heat back, but I'm actually heating. That's part of the reaction. Yes? Okay. So now, what's the last equation? D equals what?
Initial velocity. plus
No,
no, sorry.
times delta
It's,
t
yeah. Delta.
Right.
No,
plus
no, no. Yeah, correct. Half
a
a.
into delta t squared.
Yeah.
T squared.
D squared or T squared?
T.
T squared, that's right.
Yeah. Delta t squared.
You can say delta T squared or T squared, it's okay.
Oh,
We're okay. Okay. So, I want to know how long it's going to take before it hits the ground. So what do I have? I have an acceleration. I have a distance.
that's it.
So I have acceleration. I have distance. What else do I have? What is implied that I have? What's implied? The clock is right today. Look at the back. It's finally correct.
It is.
It took almost 10 weeks. 8 weeks. It's correct. We're there. I'm looking at the clock and thinking, wow. Wow.
It's physics.
What a great day, huh? Great day. A day of celebration for all the Munchkins and their descendants. Okay? So what do I have? What's implied? What is implied? I drop a rock. I drop a rock. What's going to be the final velocity? How would you find the final velocity? You'd multiply what times 10, for instance?
This 20.
I'd multiply the time by 10, right?
Yeah.
10 meters per second squared, right? Yes?
Yeah.
So I have the acceleration, which is 10 meters per second squared positive. I have the distance, which is
The time.
200 meters. I'm looking for the time, but what else am I given? What's implied in the problem? Think. Look at these equations. Am I given anything else? I'm given A. I know that. We've established that.
Now,
A is 10.
V-
So I'm given A. I'm given D.
Initial velocity.
V initial.
Initial velocity. Who said that?
So what like
Excellent.
What
Uh-oh.
No.
Muhammad is shouting at him in Arabic. I don't think you can have that. No shouting in Arabic. No shouting in any language the teacher doesn't know. Okay, so
I object.
Give it.
the
I take the credit.
the
No.
Muhammad wants the credit. Shall we give him the credit?
No.
Yeah.
No. Yes.
The man from Delhi says no. Okay, now. So
Yeah, I'm Indian.
okay. It's getting very, very heated in here. You know, these guys get very crazy about mechanics.
No,
Okay,
Indians get.
Sir, we love
Okay.
physics.
we love physics. Okay, Muhammad. Okay, we're impressed. So we have the initial velocity is 0. So what equation am I going to be able to use here? What equation am I going to use? Well, I'm given the initial velocity A. Okay, delta t. Can I use that one?
No.
No, I can't use that one. Can I use this one?
No, you can use the second one.
Am I given the final velocity?
Uh,
Which equation can I use? 1, 2, 3. I'm given distance,
Thirty.
initial velocity, I'm looking for time, so which one? I need an equation where all the variables are satisfied except for one. Which one? 1, 2, or 3?
Three.
three.
Number 3. So I want to solve for t, correct?
Yeah.
Now, look at what happens. I'm going to write the equation over right here. Is that okay? Because I want to mess around with it. This equals 0. Do you see that?
Yeah.
Because the initial velocity is 0, so it equals, the term equals 0. So d equals 1/2 gt squared. Correct?
Yeah.
Yes or no?
Yes.
Okay? So I want to solve for t. Multiply both sides by what?
2.
2.
Okay.
Divide by g. That's going to equal t squared. But then, how do you solve for t? Wouldn't it be t equals 2d over g, square root? Yes?
Yes.
Yes? Now, you know what we can do? We can reduce that even more for free fall. For free fall, what's g always? G is a constant. It's 10, right? So what's 10 divided by 2? What's, 1 over 10 is 1 over 5, right? So do you see how I can reduce this equation? Okay? I can reduce this equation. There are two conditions, though. There are two conditions. Free fall, right? And the initial velocity equals 0. So if you have initial velocity 0, and what am I? Free fall. Okay, so what is that? When you say free fall, you say that what? G is 10. So initial velocity is 0, so that term drops out. And what two things are you comparing? D and T. You got to compare D and T. Okay, so if I have, let's erase this. Where's the paper towel? Is there a paper towel around anywhere? Oh, here, I got one. I'm going to erase this. Is that all right? So there are three conditions. There are three conditions, okay? Right? And the third one is compare D and T. Okay? You all right?
Yeah.
Everything all right? You're not having a crisis there, are you,
No.
one of you? Everything's okay? Okay, excellent. We don't like crises in physics. Okay, so, can we solve the problem?
Yes.
So what is it?
Uh,
T
equals
200
over 5
over 5.
40 roughly 40
What's the answer?
spread
Root 20, which is 2 root 5, right?
2, 4,
Which is,
6.3.
what is it?
6.3
6.3. Don't forget, we don't leave things in radical form. Didn't we go over that last time?
yes
Yes.
We don't leave things in radical form. I have a clock right there. I feel so important. I know what time it is. This is incredible. The production value of these videos just went sky high. Do you think?
yes
Okay? Mohammed likes to stand in the back. He likes to kind of like, it's like rocking and rolling back there, okay? So the production, you think I'm looking right at the camera, but I'm actually looking right at the clock.
and
Can't even tell, It's excellent. I'll tell you, production value is up here now, okay? Now, so, you get it?
Yeah.
All right, now, let's keep things rocking and rolling, okay? And what's the next question? It says, at what velocity did the rocket hit the ground? Now, I just want to say to my boss who's standing right there, right? I just want to say, I want him to realize how the production value has gone sky high. Are you ready? You ready? Why has the production value gone sky high?
The clock is.
The clock is working. You see? He's impressed. I like it. All right, so what velocity will it hit the ground? We can use this, right, can't we?
Yeah.
Right?
Yeah.
What's the initial velocity?
0.
0. What's A?
10.
What's T?
Velocity.
6.3.
6.3. What's the final velocity? Final velocity equals
63.
10 times 6.3. So the final velocity equals
63.
63, what, gorillas?
Are you guys rounding 8 to 10?
64.
Yes, not 9.8 is 10. We don't,
I like that.
yeah, I have approval. I feel like my day is
No, but
complete.
that guy, in that book, he did, the conceptual physics, he taught the rounded to 10, and when I started doing that way, it was always.
It's a lot easier, I know.
Yeah,
I
because you're
know.
like, oh,
I know, exactly.
so do you make it on 10 on the test, or 10 just?
10, always 10. It's easy to, the reason we use 10 is because it's easier to approximate, judge, things like that. So we got one more? What was the average velocity? What's the average velocity? It's not up there. The equation's not up there. We did the equation the very first time.
Yeah.
What's the average velocity?
Minus velocity.
Well, you can do it two ways, right? The average velocity equals the initial velocity plus the final velocity divided by 2. Now, when can you use that equation? If what is constant?
Speed is gone.
No?
Acceleration.
Acceleration is constant. Okay? So the average velocity would be what? 0 plus 63 divided by 2 is
1.5.
31.5 meters per second. Are we done? Are we off?
Yes.
It's a wrap. Excellent.
Bye, don't miss
I
out.
like
See you
it, I
next
like it, I
time.
like it.
Excellent. Excellent.